somebody just ate right now. So glucose is going to end up being used for glycolysis, which is the splitting of a sugar molecule, specifically glucose, taking a 6-carbon glucose into 2 3-carbon pyruvate molecules. Now pyruvate, in just the fed state right now, consider that many of these pathways, they were sort of hungry for glucose, and now that glucose came in, they're happy. Pyruvate is going to enter into the mitochondria. Now some of this is a review from last week. Pyruvate enters into the mitochondria now, 3-carbon molecule, and pyruvate gets converted into something called acetyl-CoA, or in medicine they'll often refer to this as acetyl-CoA. And again, we're going to go into so much more detail, but pyruvate has 3 carbons, acetyl-CoA has 2 carbons and a CoA added to it, the pantothenic acid I mentioned last week. But a carbon comes off, and anytime a carbon comes off, it's going to come off in the form of CO2. So you can see that we're making some CO2 right now. Again, that's going to come in handy later on. So glycolysis, glucose comes into a cell, into the cytoplasm. In the liver, it enters in the GLUT2 transporter, enters in, goes through glycolysis, gets split into 2 pyruvate molecules. In an oxygen-rich environment, pyruvate enters into the mitochondria of this liver cell and gets converted to acetyl-CoA. Now, acetyl-CoA is the entry point for the citric acid cycle. The citric acid cycle, when we talk about this, you'll see is actually not a it's not a cycle, but it's more of a traffic circle. And the reason why is because there's a lot of things that can enter and exit at many different points in this particular cycle. You've heard of the citric acid cycle as the Krebs cycle, maybe the tricarboxylic acid cycle, but pyruvate turns into acetyl-CoA, and now acetyl-CoA is going to condense or combine. The 2-carbon acetyl-CoA combines with the 4-carbon oxaloacetate. None of this is important right now. Oxaloacetate to form a 6-carbon molecule called citrate. And I just briefly abbreviated these, but as the citric acid cycle goes around, essentially what's happening is the citrate becomes isocitrate, alpha-ketoglutarate, succinyl-CoA, succinate, fumarate, malate, oxaloacetate, which will recondense with another acetyl-CoA molecule called citrate again.